Hey, so we've talked about Boyle's Law, we've talked about Charles' Law, we've talked about Gay-Lussac's Law, and now today we're going to put them all together and talk about the Combined Gas Law. Okay, today we talk about the Combined Gas Law, and our target is to be able to use Boyle's Law, Charles' Law, Gay-Lussac's Law, and the Combined Gas Law to solve problems relating to pressure, volume, and temperature. So let's go ahead and talk about the Combined Gas Law. The Combined Gas Law is what it sounds like, okay? It is, we've talked about these three gas laws involving pressure, volume, and temperature. And what the Combined Gas Law does is it literally combines all three of the gas laws and puts them together into one combined gas law, right? So if you'll take a look at Boyle's Law and Charles' Law and Gay-Lussac's Law, what you'll see is that the pressure and the volume are always in the numerator of the equation. And the temperature is always in the denominator of the equation. And so what we're going to do is we're going to take the pressure and the volume in the numerator, the temperature in the denominator, and set them equal just like these other gas laws. All right, so look at the Combined Gas Law. We've got P1 times V1 over T1 equals P2 times V2 over T2. Right? And just like always, P is pressure, V is volume, T is temperature, and 1 and 2 is before and after. Right? So here we have a combined gas law we can use to solve problems involving all three of the gas variables, pressure, volume, and temperature. So let's go ahead and let's take a look at an example of using this to solve some problems. All right, if you were able to solve problems about Boyle's Law and Charles' Law and Gay-Lussac's Law, this one should be no problem. It's really kind of very similar. So let's take a look at this problem. It says a gas is heated to 80 degrees Celsius and a pressure of 180 kilopascals. If the container expands to hold a volume of 800 milliliters, what was the volume of the gas at a temperature of 50 degrees Celsius and 120 kilopascals pressure? Okay, so now in the Combined Gas Law here, we now have 6 variables we need to take care of. Okay, there's 2 pressures, 2 volumes, and 2 temperatures. The problem's probably told us 5 of them, and we're going to figure out the 6th one. Okay, so let's take a look here. The first number I see is a temperature, 80 degrees Celsius. That will be my temperature 1. So I'm going to need pressure 1, volume 1, and temperature 1. My temperature 1 is 80 degrees Celsius. And just like all the other problems I've done, my temperatures need to be in kelvins. So I'm going to right away add 273 and turn this into kelvins. So let's see, that'll be 353 kelvins. Okay. The next number I see is a pressure. It says the pressure is 180 kilopascals. So that'll be my pressure 1, 180 kPa. And let's see, it says that the volume is 800 milliliters. So my volume 1, 800 milliliters. Okay. Now it says that later on, the pressure is 120 kilopascals. So that is my P2, 120 kPa. It's asking me to find the volume at that time. So that's V2. And it tells me the temperature is 50 degrees Celsius. So T2, 50 degrees Celsius. And of course, I need that in kelvins. So I'm going to add 273. And that's going to become 323 kelvins. Okay. Now let's take all those numbers and let's put them into the Combined Gas Law. I'm going to come over here. It said that P1 V1 over T1 equals P2 V2 over T2. So pressure 1, it said, was 180 times V1, which was 800. Keep in mind, pressure and volume can be in any units. It's just that the 2 pressures need to have the same units and the 2 volumes need to have the same units. Okay, now on the bottom here, T1, I have 353. Okay. And then I have P2, which is 120, times V2, which we don't know. So I'm going to write V2 over T2, which I have 323. Okay. Now what we're going to do is we're going to cross multiply. Okay. So I'm going to take, you could simplify this here and then cross multiply. I find it easier to just do it all in one step. You do what works for you. So when I multiply it this way, I'm going to write it all out just to be really clear. 353 times 120 times V2. And when I multiply this way, I have 323 times 180 times 800. And then what I'm going to do on my next step is I'm just going to simplify things here. All right, so I'm going to take my calculator. And here I'm going to multiply 353 times 120. And I'm going to get some big numbers here. 42360 times V2. And then on this side, I'm going to multiply those three numbers. So that's 323 times 180 times 800. And I get a really big number here. 4651200. And then just like every other problem, I'm going to divide to solve the equation. So I'm going to divide by 42360. So I get V2 equals, I get 1098. That is a volume. It should have the same units as the other volume. The other volume was in milliliters. So this is in milliliters. There we go. There's the other volume. So not too tough to use. Pretty similar to our other gas laws that we've talked about and we've learned about. You're going to end up with some big numbers here, but don't let that intimidate you. They're just big numbers, right? All right, so there is our combined gas law. We've talked about Boyle's law, Charles' law, Gay-Lussac's law, and now the combined gas law. After this, in the next target, we're going to go on and we're going to talk about a couple other gas laws. We're going to talk about Avogadro's law and the ideal gas law. But that'll be in the next target. So for now, hopefully that helps us be able to use those various gas laws to solve problems. Yeah, until next time, take it easy.